Alright, here we have our HO11. It's only one minute and then we hear that. Today we are working on a 2017 Buick Encore. We are going to be looking at our oxygen sensors. So for sensor 1, that's going to be our upstream sensor, and then sensor 2 is going to be our downstream sensor. Here are the readings at idle. We're getting about 0.7 bouncing back and forth and 0.6 volts for our oxygen sensors. Our downstream short-term fuel trim is not going to actually see any readings because downstream doesn't mess with the fuel trim at all. But as you see when I put load on the engine, our short-term fuel trim for the sensor 1 will change. Right now we are cruising about 2,000 RPMs. Alrighty, and then as we come off, it settles back down. So now we're gonna unplug our HO112 sensor, our upstream oxygen sensor, and see what happens to our PID values.
Restart that shit.
Alright, now with our oxygen sensor unplugged, we're gonna go back. And with that unplugged, our short-term fuel trim is going down significantly. We're going down with that unplugged, the car will start.
It's down here.
Oh, install.
Yeah.
That's like.
So we're looking at the wiring diagram for a 2013 Ford Focus here. We can see sensor 1.1 and sensor 1.2. Obviously it's a 4-cylinder, it's only going to have one bank. We can see just by looking at the wiring diagram here and the style of how it's laid out that the upstream here is an ion pumping style, and our downstream is just a regular heated O2 sensor, oxygen sensor. So back here we can clearly see our upstream, our downstream is hiding down there, and then if we look up here, we have our downstream connector and our upstream connector at a nice easy access point right there.
So right now we are looking at the PIDs for this 2013 Ford Focus. We are idling right now, and as you can see, our short-term fuel trims are negative 3.9 and a little bit lower, and our long-term fuel trim is bouncing between 8.6 and negative 9.4. Our oxygen sensor output voltage for our bank 1 sensor 2 is at 0.625, which is on the lower end. And then our lambda reading is sitting at 0.989 and is spiking up to about 1.0, which is perfect for idling conditions. As we increase engine RPM, we see our short-term fuel trims balance. As you can see, we're still running a bit. Trying to get sitting around 2,000 RPMs. And as we go back down to idle, yeah, we're still running a bit rich. This Ford Focus does have a few different problems in DTCs and codes, so alrighty, so we've created a very small vacuum leak to try to get the engine to run lean. As you can see, our short-term fuel trims are at 18.8. There we go. Alright, and we have just created a vacuum leak to get our engine to run lean. As you can see, our short-term fuel trims just spiked from 20 to 10, and they're proceeding to go back down as we plug back in the vacuum leak we created. All right, so here we are again at idle with all of our sensors and everything operating normally. I was like, we're looking at our lambda values. Our rich lambda value would be below 1.0, and then a lean lambda value would be higher than, it would be like 1.1 or like 1.2 or higher. That'll be a lean ratio. Alrighty, so now we're about to create an engine misfire just so you can see what happens when we unplug one of our ignition coils. Alrighty, we're about to force the car to run rich. We're about to add some propane. Alright. As you can see, just with that little bit of propane, the engine is already starting to run noticeably richer.